Friends, in this video we are going to study the program control transfer instructions of 8086 microprocessor. In this category, the program control transfer instructions, we have three instructions: call, return and jump instructions. So let us start with our topic. The program control transfer instructions are those instructions which transfer the control of the program or the microprocessor from the main program to some other memory location. Suppose the main program, it is written at some memory location in the microprocessor, like from 8000 memory location the main program is written. Now in this main program, if any of the program control transfer instruction like call, or jump instruction is written, then these instructions, they are going to transfer the control of the program or the microprocessor from this memory location to some other memory location, suppose like 9000 memory location. Okay, so they are breaking the sequence of the program, of the main program, and they are making the microprocessor to jump at some other memory location. Now at that memory location, some program will be written that is known as either a subroutine is written, or we can say a small program or a procedure is written. So microprocessor, it is going to jump at that memory location. It is going to execute all the instructions which are written in that procedure, and then afterwards it is going to return back to the main program and execute the remaining instructions of the main program. So here, because the control of the microprocessor, it is transferred, or the program control is transferred from one memory location to another memory location, so they are known as the program control transfer instructions. Now under this category, there are two type of instructions. One is the unconditional transfer instructions and second is the conditional transfer instructions. So there are two types of such instructions: unconditional and conditional transfer instructions. By the name, it means that unconditional means that there is no condition. Whenever this instruction is written in the program, the microprocessor has to jump to some other memory location. And conditional means that it is going to transfer the control only when that condition is satisfied. Now in the unconditional transfer instructions category, we are having the instructions call, return and jump instructions. And in the conditional transfer instructions category, we are having the jump instruction whose notation is J, and then the condition is specified. So these are the program control transfer instruction, unconditional and conditional. Let us start with the call instruction. Now the call instruction, it is used to transfer the execution of the program or the microprocessor from the main program to a sub program or the sub. Okay. Now the call instruction, it is of two types: near call and far call. We know that in the 8086 microprocessor, the address of a memory location, the physical address, it consists of two parts. One is the segment address and second is the offset address. So the address of a memory location physical address, it consists of two parts: segment address plus the offset address. Now segments, there are four segments: data segment, code segment, stack segment and extra segment in the 8086 microprocessor. Now these segments, suppose the main program, it is written in the data segment, or we can say in the code segment it is written. So it may be possible that the sub program or the procedure where the control has to be transferred, that sub program or procedure is written either in the same segment or in another segment. So if it is written in the same segment, then there is no need to provide the segment address, only the offset address will be provided. Offset address means that in that particular segment, that is the memory location where the program is written. So if segment is same, then there is only the need for the offset address. If suppose the subprogram or procedure it is written in another segment, then complete address, physical address has to be provided. So depending upon that, there are two types of call instruction. Near call means that the subprogram is written in the same segment, so only offset address will be provided. And if the subprogram or procedure it is written in a different segment, then it is called far call instruction. So there are two types of these instructions. A near call is a call okay, that is the near call instruction. Far call, so in the near call, because it is present in the same segment, we have to provide the offset address. So the stack pointer it is decremented by 2 and the offset address of the next instruction after call is stored in the stack. Why it is done? Because suppose in the main program is written here. Now here we have encountered a call instruction in this main program. So microprocessor has to jump to the memory location where subprogram is written. So that memory location will have one offset address plus it is going to have the segment address. Now the instruction which is written after the call instruction, because the instruction pointer IP, it always is stored the address of the memory location where the next instruction is written. So the instruction after the call instruction, there its memory location will also have a offset address plus a segment address. Now segment, because it is a near call, so segment address will be same for the main program and the sub program. So there is no need to store the segment address, only offset address where the next instruction is written, that will be there in the instruction pointer. So that address of the offset address of the next instruction after the call, that will be stored in the stack. Stack is always used to store the temporary data. So stack pointer is the memory location from where the stack is initialized. So stack pointer, it is decremented by 2, and then the offset address will be stored. After that, this instruction pointer, it is loaded with the offset address of the sub program. Okay, that is the case of the near call. Now when we are having the far call, then the complete instruction pointer, because offset address is also changed and segment address is also changed, so complete physical address which is there in the instruction pointer, that will be stored in the stack pointer. Stack pointer will be decremented 2 times. First the offset address is stored, and after that segment address is stored, and then this instruction pointer is loaded with the physical address of the subprogram, so that microprocessor can jump to the memory location where that procedure is written. Okay, so that is the method which is followed whenever this call instruction is executed by the microprocessor, and how the addresses they are stored in the stack. If we see some example of this near call and far call, for near call, we are having an example called Pro. Pro is the name of the procedure, okay, which we want to execute, or we can say Pro is the name of the subprogram. After that, call CX. Call CX means CX is containing the address of the first instruction. Okay, so offset address of the first instruction of the procedure, so that will be loaded, that is replaced, it is going to replace the contents of the instruction pointer with the contents of the code segment. Okay, so this is an example of near call. Far call will be call d word pointer 8x. Okay, so the code segment means the segment address and the instruction pointer, they are fetched from the memory locations, and the new value of the code segment, that is the new segment address, that is fetched from the pointer which is pointer 8x and 8x plus 1, and instruction pointer, here 4 memory locations will be used. These memory locations, they are the segment address, and these 2 memory locations are the offset address. So here you can see that only offset address is provided, and here both segment and offset address is provided. So that is the call instruction. Now when the microprocessor, it jumps to the memory location where the subprogram is written, after the execution of the instructions in the subprogram, it has to return back to the main program to execute the remaining instructions. So at the end of the subprogram, another instruction is written which is called the return instruction. So this return instruction, it is also a type of program control transfer instruction, because it is transferring the control of the microprocessor from the subprogram or the procedure to the main program, so that it can execute the remaining instructions. So this instruction, it is going to return the execution from the procedure to the next instruction after the call. Okay, now when it is near call, when it was near call, then only we need the offset address, so instruction pointer is again now replaced with the contents which are stored at the top of the stack. So instruction pointer is loaded with the contents of top of the stack. Because in the stack at the time of call instruction, the address of the next instruction was stored. So when it is returning back, it is going to again retrieve back the addresses from the stack, and that will be loaded in the instruction pointer so that the main program execution can be resumed back. Now when it is the case of far call, it has to pop the contents of the stack 2 times, because it has to get the segment address and it has to get the offset address also. So in the case of far call, the 2 pop instructions are used. At the time of first pop instruction, it is going to get the segment address, and after the time of second pop instruction, it is going to get the offset address. So this is the return instruction which is used to resume back the execution of the main program from the procedure, returning back from the procedure. Now if we take the example of the return instruction, suppose that in the main program we have called the procedure PRO. Now in this procedure we have written the instruction move AX, so this instruction will be executed. At the end of this procedure, the return instruction is written, so it is going to return back to the main program where the call instruction was written. Now next instruction is the jump instruction. You have seen that all these call and return and jump instruction, they are the unconditional instructions. Means they are transferring the control, there is no condition, and whenever this instruction is written, the microprocessor has to jump to other memory location. Third unconditional transfer instruction is the jump instruction. Now jump instruction is also of 2 types, short jump and far jump. Jump means that it is going to jump to some other memory location. So just like the call instruction, if the memory location where the microprocessor has to jump, if it is in the same segment, then it is called a short jump. If it is present in a different segment, then it is called a far jump. Okay. Example of this are, if we want to use this instruction, then the syntax for this is jump and then we will write the target address. So example is like if we have written move AL05H jump label 1. Label 1 is the address of the memory location where the microprocessor has to jump. So label 1, at that memory location another instruction is written. So move 2000 H A L, and after that return is written. So this is going to return back to this jump instruction, and after that suppose another instruction is written move AL00H. So what the microprocessor will do, it is going to, when it is executing this jump instruction, it is going to jump to the memory location where this label is given. Okay, label 1 is just we have written a we are just defining that memory location. Okay, here the address will come. Now at that location this instruction is written, so microprocessor will store the address of the memory location where the next instruction is written in the stack. It is going to jump to this location, execute this subprogram, return back to the main program, and then execute this instruction. Okay, just like the call and the return instruction, jump instruction, they always store in all these three instruction. Microprocessor will store the address of the next instruction in the stack only. Okay, so all these were the unconditional transfer instructions. Now in the conditional transfer instruction we are having the conditional jump instruction. Conditional jump instruction, then syntax will be like J is written and after that condition is written, and when this condition is satisfied then only the microprocessor will jump to another memory location. Now here the jump will always be the short jump. Okay, means in the same segment the microprocessor is going to transfer the program control. Okay, now there are many conditional jump instructions like jump on carry, jump on no carry. Jump on carry means when the carry flag is set, then only the microprocessor will jump to another memory location. Jump on no carry means when the carry flag is reset. Then we are having jump on zero, jump on overflow. Now these conditional jump instruction, they always use the conditions on the carry flag. On the flags. Now there are various types of flags in the microprocessor like carry flag, zero flag, parity flag, overflow flag, sign flag, auxiliary carry flag. So all these flags, they are conditions because the flags are set and reset due to some operations, mathematical operations occurring in the microprocessor. So whenever due to any of these mathematical operations, if the flags are set or reset, then we can use those conditions in the jump instructions. Okay, so here there are several jump instructions which are related to these flags. Okay, now when this condition is true, then only the microprocessor will jump. If it is false, then the microprocessor is not going to jump to another memory location and it is jumping in the same segment. Okay, so here in this video we studied about the program control transfer instructions which are available in the instruction set of 8086 microprocessor. We studied that there are two types of program control transfer instruction, conditional and unconditional. In unconditional we studied the call, return and jump instruction, and in the conditional we studied the jump condition instruction. So I hope that this topic is clear to you. Thank you.